Recording.
Hello all, good morning, good evening. Let's give a couple of minutes for more people to get in. Actually, we have close to 35, 40 people in this meeting. We can get started. Okay, good morning, good evening all. We can get started as the people come in. Um, Welcome all of you to this Magma 5G, everything you need to know meeting. Yeah, today we are going to have Yogesh and Bo from Wave Labs and Govindrajan from ARM, who are going to jointly present a lot of updates on the Magma side, what's going on in the community, what is the release status, and what's we could expect in the upcoming roadmap and stuff like that. So thanks Yogesh, thanks Govind for joining us.
Thanks for this.
Yeah. So we have interesting updates today from the agenda. We could see that I'm going to present on the enabling the adoption of Magma here. And with that short talk, I will hand it over to Yogesh and Ganesh for the Magma dev updates, test and ops updates, which is going to take quite some time. And then we will invite Govind here to present on the ARM ecosystem for the Magma. What's the ARM enablement done so far, and how it's going to benefit the community and how it's going to help us. And last, we could be able to take some of the questions. We could discuss on the next meeting plan and we could close on it. So with that, I just move forward. I think I see most of the participants are coming here often to get to know the Magma's updates. Yeah, and I see a few of them are new here as well for the newbies. So the main objective of this meeting is to see that what are the 5G development updates from the existing features and what's the roadmap going on. And at the same time, how this Magma is actually getting aligned with other of the open source communities like Elephant, Super Blueprint, and other open source communities where we could be able to collaborate, integrate together, and bring Magma as a whole to the whole world as a useful product for the adoption. So along with that, this to move forward and enabling engagement, collaboration, and adoption of Magma is the key here. And you could see that Magma is actually really getting up much traction because it's going to be much useful in the Industry 4.0 evolution. And it is going to help us in a lot of fixed wireless access as well as in the edge computing deployment. So Magma is going to help us a lot as we adapt more and more, and we are getting into private networks as well. And it is actually getting doubled up every year in the past year as well. And we have a lot of future, a lot of opportunities for all of us. And last but not the least, Wavelabs is actually giving a dedicated channel for support of Magma and enabling and adoption of Magma in a lot. There are a group of Magma specialists available in this channel, Wavelabs 5G support. It's a message away. All of you are invited to come here and take help. Okay, anytime, any help you needed. And Wavelabs is also kind enough that they have put together a ready-to-use AWS-based orchestrator. All is you can bring up an AGW, come here, plug it in, and we can start using it, explore it more, try to get it to the next steps. So with all that, I hand it over to Yogesh and Ganesh to give a dev and ops update.
Thanks, Bhagavan, for the quick intro. I think this has been really exciting. The September of 2022 was really exciting because we have full-fledged what 5G SA feature getting released in 1.8. So I will request Ganesh to give a quick updates on what are the features which are available or delivered in 1.7 and 1.8. Ganesh, over to you.
Thank you, Yogesh. Yeah. You see, like as part of 1.7 release, Magma supports all basic procedures and validate all basic registration and basic authentication, video session establishment, and all UE initiated sessions and day registration. And you can see this basic in detail, all these procedures, how it work, all these things. You can go through this release document. Parthiban, can you move to next slide? Yeah, in 1.8, we mainly focused on the quality in what Magma, and we fixed many critical issues, and we improved the code quality with coverage, and we tested with the different open source tools, and we enhanced additional features. One is like a QoS support and stateless feature, and these are the new features we enhanced. And these features mainly focused on with respect to end user, provides the optimum, like end user perspective, what features are required. Those features we enhanced in 1.8 release and validated thoroughly with the different open source tools. Yeah, Parthiban, can you move to the next slide? Yeah. What benefit, like what 1.8 is, why 1.8 is better than 1.7, whether it is production release or not, where can we configure or not. So mainly how we can decide is like we improved the UE end user security features. One is a SUSI, and we resolved orchestrator endpoint security issues we resolved, and we enhanced additional QoS support with the control plane and user plane, both the sides, and make sure like recoverable, like we made Magma as a stateless support. Like when any problem comes in Magma, it automatically recovers, and it all the sessions will be recovered from the original state. Like user perspective, services will not be any effect. and performance we improved, while performance improvement we provided by reorganizing the data structures. We optimized some of the code structure and test coverages. Test coverage, we have enhanced all the unit code coverage. We improved by adding the unit test case, by verifying the open source tools, and thoroughly we tested with the different commercial tools, uh, and we improved the quality in the 1.8.
Perfect.
Yeah.
So yeah, adding up to what Ganesh has already covered. So I think moving from 1.7 to 1.8, the biggest challenge was 1.7 was more like a first time introducing of 5G, and 1.8 we were thinking that what could we do to make it production ready. All the features which are also commonly available in other open sources. We wanted to have that, plus all the options which you are seeing there, to make sure that it is, it can be taken up to the field and deployed. Already, folks in the community and some of our customers have taken it for trial. They are doing the lab testing, and we are getting positive feedbacks from them. So from just giving a little bit more detail on the features which you have shown here. The SUSI extension, whatever you see, it helps in uh, even encoding the IMSI, so that from the first message itself, which is sent by you, is completely encrypted based on all the 3GPP specs, profile A, profile B. It basically points to the different algorithms to use for encryption and decryption. Orchestration endpoint tuning was again, some security vulnerability reported, so we ensured that those are addressed. And from I think a lot of work has gone in for quality of service. The QFI feature, where it strictly follows whatever the QFI exchanged in 5G while video session creation, that is followed, and it goes for the mapping of it maps to the correct features that has to be provided. And session modification, this was again one step for the network initiated modification feature. The main goal is finally to connect it with the PCF and give the user the flexibility to change the QoS and other parameters dynamically. It also will enable us to support VONR going forward, because there we need to have connection with PCF and the subscriber management. So that is a feature. Mostly it is the main work which has gone in is in AGW. There is some minor work which is still needed in Federation Gateway. Hopefully going forward, all the end-to-end testing will be done in upcoming release, and we will be ready to go to provide additional features. Recoverability, as again Ganesh mentioned, uh, uh, the state management, making it agnostic to restarts, so there should not be any additional control plane exchanges in the event of restarts, and in cases where queue is not behaving as expected, all the cleanups are happening properly. That's where we have taken up this implicit deregistration and state management, which is stateless. Uh, uh, Parthivan, am I audible? My audio is better.
Yeah, can you be a little more louder, Yogesh? I think looks some
Sure.
background noise is there, or
Yeah. There is no. Okay. Yeah. Let me just ensure that. Is it better now?
Yeah,
Batman?
it's really better. Yeah, it's really better. Yeah, please go ahead.
Oh,
Yogesh.
sorry for that. Yeah. So we have actually done a lot of things in performance improvement. I think we have optimized a lot of existing infrastructures in Magma to support like the attach rate, number of users that has to be done. So those kind of improvements we have done. And test coverage wise, uh, uh, based on open sources, there's various simulators which are available in open source, all the commercial simulators, the real equipments. Uh, we have done all the testing with these things to make sure that it's of good quality and it can go for the next level of field trials and field deployments. Um, uh, let's go to the next slide, Parthiban.
Yep.
Yeah. So coming on to the test coverage, what all we have done as part of 1.7 and 1.8 release. You can see all the 1.8 features and 1.7 features. So basically, what we wanted to ensure was whether it is CI/CD, open source tool testing, commercial simulators, daily regressions, everything gets covered here. Also in 1.8 release, we added support of IPv6 and IPv4v6 together. And we have enhanced the existing OpenV switch to support the QFI. This feature, I think, it's not there in the native OpenV switch, and we have done it for the Magma community. Regarding the test reports, we generate test reports on a daily basis. You can see the WL5G tab, which is highlighted. So it has around 200 plus, 250 plus test cases, which runs on an automated tool called Abbott. And also we run regression on Spirent. So the result, the output is a mixture of both the commercial tools. And also as part of the release activity, we do longevity test, CPU and memory benchmarking, throughput testing. So all the results are available in the release channel, the link which Ganesh showed in previous slides. So 1.8 has the contents and the release reports regarding the various throughput and the benchmarking numbers that we are having. So integration testing, as we can see, that runs on a daily basis on the packages, and the links are shown here. Scale test, we have, as part of 1.8, we have tested around 200 UEs, 4 sessions, 4 policies, 400 Mbps, and 5 attach state. The netting stateless enable features are all there, and we have tested with 12 GNBs. For the real equipment testing, we have tested it with Bicell, radios, TNW, Genix farming, and various sensors like Huawei, Mid-30, and other real equipments. The support we are looking from the community, and the community has been very helpful. If they can help us in providing labs where we can do more and more interoperability testing and the near field deployment testing, that would be great. We can get the community support, because one of the benchmark for the releases are it has to be tested on the real equipments, real GMP and real UE. So that would be great if community folks can help us in that. But we make sure that whatever is the at least 1 or 2 real equipments gets tested on. Yeah.
That's a awesome thing, Yogesh. So now that we are adding more and more GNBs into the list of Magma compatibility and interoperability happening, it will be nice if the community members come forward. We are ready to do and more interoperability testing, make the Magma works with more and more radios available in the market. That way the adoption happens more. So we invite people. Wave Labs is ready to jump in and support on getting the interoperability done. So please do message us. Please do reach out on the Magma Slack channels. We are available. So Yogesh, you want to talk more in detail about the PNW testing which was done recently after the GenXCom?
Yes, so I think this new TNW radio we purchased, and all our testing was done as part of the 1.8 release testing was benchmarked against the TNW radios, and we have tested with the UE as well as the CP device, and all the basic functionality seems to be working fine. All the basic registration, service request, and all the basic procedure seems to be through. You want to add something, Pratibhan?
I think that's a good update, Yogesh. We have done both on the CPE devices as well as on the UEs. The 5G enabled UE is available. It is done at the various locations as well. It is done both in the China lab as well as in the US labs. So we have a wide variety of UE and the CP covered out of the test. And it gives a confidence that Magma is now production ready. It can go out as an edge compute as well as on the FWA and use cases and private 5G use cases as well.
So let's move on to the next slide.
Anything more to add, Yogesh? If not, we could move forward.
Yeah, no, I think for the test and ops update, I think that's pretty much it. Maybe we can go to the roadmap.
Yeah.
Yeah. So these are few of the items we are planning for the upcoming release and Q1 of the next year. So for release 1.9, which is the next release, all those containerized services are available on 1.8, and we have done some basic sanity of 5G features on top of it. But we want to make sure that all the test case which have originally been designed and tested for the Debian-based packages, everything with same scaling numbers or better with an improved versions runs on the containerized environment of AGW. So that is one of our primary targets. And we have identified a couple of more radios. And the idea is to have new 5G radio vendors. Some of them have approached us, and we got some new contacts. And the idea is to have more and more coverage with real equipments. And the improvements, there are a couple of improvements we have identified as part of the existing code based on the various feedback we have received. So we are going to do some improvements where we'll be adding some logs or some statistics so that we can get all these things with helps in the deployment, debugging in the installations. For the next quarter, for 2023, Q1 Q2, our idea is to have this features integrated with OSS and BSS systems so that can get the real-time charging infrastructure integrated. There are some discussions on the Magma features, so there is some layer of changes we have to do to adapt to that. Also, slicing features, there are a couple of proposals we have put forward. We'll pick a couple of them and we'll target for Q1, Q2 for 2022. Also, on similar lines as S1AP, there is a new testing framework which is developed. It's like NGP tester. So the idea is every commits whatever we are making, all the P0, P1, that means all the critical test cases are getting covered as part of that. Every commit will have this test running. So any issues or any integration. So yeah, meaning it's a community driven activity and we are part of this integration tests. There are a couple of other items we have identified, and we have put it in the links which is there, like roadmap items for discussion. We have identified what are the other 5G use cases or 5G features which can be taken up, and we have provided some kind of priority to it. And we have circulated in the past, but the idea is if we can get feedback on those proposals or those line items, it will be good. We can help us in prioritizing the items, like what can be taken first, or what can be deprioritized. So that will be one more real interesting, real good feedback can get from the community. That will be great.
Yeah, so on the same context, what Yogesh is pointing out is all these roadmap items for discussions are available in the Magma wiki, and the meeting notes available over in the Magma meetings channels as well. So the request is if there are adapters who are adoption of Magma people who are looking for some of the key features within Magma, then we invite you to come and give us the feedback that will help the community and large, so that as a community, we could be able to decide what is being prioritized by the adopters who are adopting Magma, with the service providers or enterprises who are taking up Magma. So we could be able to prioritize those features, and we can start implementation of it, make it production ready. We can make it added into the Magma feature list. So that's the idea behind it, what Yogesh is pointing out. So we invite the members to come forward, give us your inputs, what's more priority for you, what's being expected out of Magma in the 5G context, so that we could go ahead and make it done as a community. Any more items, Yogesh?
Yeah, there is one, I think there was a few other items we are taking up. Maybe you can go to the next slide.
Yeah.
Yeah, there are some other improvements which we are trying to see, especially on the registration, the max UI supported, and the throughput, how it can be improved. So we have identified a couple of places. So it's like we are not directly putting on Magma. We are just making sure that everything works fine, and then we'll take it forward. So we have identified what are the tuning points, or how we can achieve those in better throughput, better performance for doing this. So as part of this, we have done some kind of optimizations and debuggings to achieve this.
Yeah. So in this slide, what Yogesh is trying to point out is Wave Labs is trying to make distro out of the Magma, and it is committed to make sure everything gets upstreamed into Magma. So we have started the experimentation of improving the performances over there in the Magma. Actually, we are trying to make more registration rate, allow the max number of UVs to be made, so that the mid-size operators could also pick up Magma for their adoption. Right now, it's more of Tier 2 and the rural adoption for the fixed wireless access and the private enterprises. So the whole idea is to improve the Magma performance, and Wave Labs has taken that as a separate track, and we could invite and take feedbacks on it. And these all content is going to get upstreamed in the future back into Magma community. Anything more on this, Yogesh?
Yeah, no, I think we are more or less covered.
Yeah, good. So thanks a lot, Yogesh. With that, I request Govind to take over. Govind, you like to share the screen here, Govind?
Sure. Thanks, Parthiban. Thanks, Yogesh, for the updates. Let me share my slides. Can you all see my share?
Yeah, it's up and running. You can put it in the presentation. Yeah.
Good.
Good to go, Govind.
All right. Yeah. Thanks, Parthiban. Hello, everyone. I'm Govindarajan Mohandas. I'm an engineer in ARM. I'm part of infrastructure line of business group in ARM, and I'm also a TSC member in Magma Core Foundation. Today, I would like to give an update about ARM enablement in 1.8 release and discuss about some of the ARM partner systems and ARM partners participated in 1.8 release testing activities. Finally, I would like to discuss about the Magma roadmap on ARM architecture. Coming to the status update on Magma. First of all, thanks to everyone who contributed to this 1.8 release. Specifically, I would like to thank TNG team, Magma DevOps team, Wave Labs, Radtonics, Radisys, and ARM partners Connect 5G, Circom, Hawkeye, and Nexcom for actively involved in 1.8 release activities. As part of this 1.8 release, we have created the containerized AGW image for ARM architecture. This image is now available in Magma Artifactory for the public. Now you can pull the image and run the AGW Docker services on any ARM systems. After 1.8 release, ARM is in parity with x86. What it means is AGW component of Magma it supports multi-arch, and you can now run the Docker images on both ARM and x86 based CPU architectures. Some of our partners participated in 1.8 release testing activities. I will share more details about it and in the subsequent slides. I will be explaining their device configurations and the test setup and the test results that they got after running the 1.8 AGW image on their systems. And the next one is about the Magma CI on ARM architecture. So the build CI for ARM architecture is now enabled in as part of Magma CI. So as part of the build CI, ARM AGW Docker images are getting created, and it is uploaded in Magma Artifactory. At this point of time, I would like to thank Magma DevOps team, Tim and Shubham, for enabling the ARM build CI in Magma. So the traffic CI for ARM architecture is work in progress, and I will discuss about that at the end of this presentation. So some of the ARM partners are also interested to build an internal CI, and they are willing to hook up their internal CI into the Magma CI dashboard through self-hosted runners. This work is again futuristic. I have provided the links to build as well as to run the AGW containerized image on ARM systems. So you can click those links and find the steps to build and run. And I have also shared the links for the 1.8 release blog as well as for the release notes. Please click those links and have a look. You will get more information about what happened as part of 1.8 release and what are the different ARM systems that are tested as part of 1.8 release testing activity. Now, I would like to talk about ARM partner systems and their participation in 1.8 release testing. So Magma AGW 1.8 image is tested on these ARM devices as part of release testing activities. Release testing is done with UE eNodeB traffic simulators as well as with real radios by these partners. And these 1.8 image runs fine on AWS ARM instances. It's called Graviton 2. We can pass the SRS RAN UE attached test and also the data traffic test in this AWS test setup. We had all the SRS RAN, AGW, and orchestrator, all these three components running in the AWS cloud. So that's the test topology for the AWS setup. Now you can pick the 1.8 image and put it in an AMI envelope and float it in AWS Marketplace to offer private LTE or 5G solution based on Magma code. It's not available. It's something the community can do in the future. And the next system is the NXP-based Nexcom system. So ARM partner Connect 5G ran the AGW container image on these Nexcom systems, which is the NXP chipset based. This chipset contains A72 ARM cores in it, and SRS ran UE attach and data traffic test were running successfully on this Nexcom system. And the next system is Hawkeye tech-based systems, and this team also participated in 1.8 release testing. Hawkeye team, they had 3 different test setups. One with SRS RAN, UE, and eNodeB simulator, and other one with Amerisoft eNodeB traffic generator, and they also used real radios from Sercom. Hawkeye systems is also based on NXP chipset, and it contains A53 ARM cores in it, and they can successfully pass the traffic test in all these test setups. And the next partner system is Sercom. So Sercom team, again, they also participated in release testing. So they tested 1.8 image on their gateway box. It's called Bridge Column. It's an NXP chipset based gateway box. And in that test setup, they use their own small cells. It's a LTE radio based on CBRS. So they used it in that test setup, and they could pass the data traffic test in that test setup with real radios successfully. And the next system is called SolidRun. It's an ARM device based on Marvell chipset. Connect 5G, they ran the 1.8 image on this system, and they passed the SRS RAN, UE attach and traffic test. And they have also done integration with tier 1 radios with the SolidRun boxes, and the 1.8 image runs smooth there as well. And this 1.8 image was again brought up on AdLink based Ampere machine in Carnegie Mellon University Living Edge lab. So they were using the Ampere system to run their own edge application along with the Magma core on a single box to control some of the edge devices wirelessly through a radio. So 1.8 image comes up smoothly on Ampere system. It has around 80 ARM cores in it. It's one of the powerful ARM servers that you have in the market. And the last one is the M1 based MacBook device. Thanks to the Connect 5G team, again, they ran the 1.8 image on this M1 based Mac. I think they use parallel VMs. So now developers can now use M1 based MacBook to build your own Silver network. Once again, thanks to all these ARM partners for contributing to 1.8 release. Now I would like to discuss about the ARM partners, different test setup and the test results that they got based on 1.8 image. So as you see here in this picture, this is Sercom's test setup. They have NXP chipset based access gateway running 1.8 AGW image. So it has A72 ARM cores in it. They use their own Englewood LTE radio in the test setup. As you see here, they run the orchestrator in the AWS cloud. So, so while doing the release testing, we had a common NMS page created by Shubham. Thanks to Shubham for spinning an orchestrator and sharing the NMS page with us. So ARM team as well as ARM partner team, we use the same NMS page to create our own test setup in our lab. So the orchestrator was running in the AWS cloud when we did this test. So these are some of the test results that Sercom got after running 1.8 image. As you see on the right hand side, the download speed is 222 Mbps and upload is 8.33 Mbps. They used their own CBRS Englewood radio for in their test setup. As you see in this picture, they are running the official 1.8 containerized image, and the check-in from AGW to orchestrator is also successful. So they did the UE attach test as well as the performance test using both iPerf and speed test on the UE. So these are some of the this is the SCE series of LTE CBRS product. It's called Englewood series, and this is what used in the test setup that I just discussed. Now going to the next partner system, and this is from Hawkeye Tech. So the black box is called as HK 6050. This is again an access gateway. So Magma Core is deployed on this box, and the sanity test as well as the performance test passed on these systems as well. So these are NXP Layerscape 1023 and 1043A based systems. So they have two variants. One is HK6050 and HK6010. So 1.8 image was tested on both of these systems. So as I said in the beginning, there were Hawkeye team had 3 different test setups. The first setup is using the SRS RAN E0B and UE simulator. So they have, this is the test topology. HK6050 is running the 1.8 AGW Docker image. And in this test setup, they are able to get downlink throughput of 25.1 Mbps and uplink of 13.9 Mbps. So this is the another test setup. So here they use the HK5120 as a user equipment. This user equipment is based on Marvel chipset, and it also has the LTE modules there to communicate with the Amerisoft OTS E0B traffic simulator. And HK6050 here is again running the AGW component. So in this test setup, the downlink throughput is around 139 Mbps, and uplink throughput is around 27 Mbps on HK5120 device. And this is the last test setup used by Hawkeye team. So they are using the real radio from Sercom. It's SCE4255W. That's the product name. And instead of using the Amerisoft traffic generator, they are using a real radio. And the user equipment is still HK5120, which is Marvel based, and HK6050 is NXP chipset based. So in this traffic setup, they are able to get around 107 Mbps in downlink and around 7 Mbps in the uplink. So this is based on their iPerf test, and they also ran the speed test. So they are getting more or less similar numbers comparable with iPerf. So this is yet another system from our partner. It's called Nexcom. This is again NXP chipset-based system. So Connect 5G team brought up the kernel in this device, and so there were issues while loading the OBS module because of kernel dependency. Connect 5G team resolved all those issues for Nexcom and brought up the kernel in these boxes and ran the 1.8 image. So they used SRS RAN UE and E0B simulator as part of the testing. So those tests were running without any issues. So now that we have a wide variety of ARM devices which you can use to run the AGW services in it, I would like to share how to build your own cellular network using the 1.8 image that is available in Magma Artifactory and run them on the ARM partner devices. So as you see in this picture, so this is the test setup that I have in my lab. You are free to use any radio of your choice, or you can, let me take the laser. So, I'm using a bicell radio. You can use any radio of your choice. This is the system I'm using from Hawkeye. It's HK6050. You can replace this box with any device that I was showing here. You can use boxes from Sercom, Nexcom, and you can even use M1 based MacBook. If you want to run this in AWS cloud, you can run it in ARM Graviton 2 instance in the AWS cloud. So most of you here might be knowing the steps to bring up your own cellular network, but I would like to explain it again here for the people who are not aware of it. So there are only 5 steps at a very, very high level. So the first step is to spin an orchestrator and get the network management system page. an NMS page is needed to create our own LTE or 5G network, and you have to add your gateway box as well as the radio as part of the network. So that is the first step. And the second step is to bring up the AGW system, basically pulling the Docker image from the Magma Artifactory and bring up all the AGW services in this box. And the third step is hook up your own radio of your choice. And this radio comes along with eNode B in the case of LTE and gNode B in the case of 5G. So those services will be up and running in this. You can even use the Sercom Englewood series. And there are a few more products from Sercom for they offer several 5G radios as well. So you can use any of them here. You can even use tier 1 radios as well. So that is step 3. And step 4 is adding this access gateway and eNode B as part of the LTE network that we created in the NMS page. And finally, add the IMSI number for the subscriber in the NMS page. And the last step is to burn that IMSI number in a blank SIM and put it in a cell phone. So these are the 5 simple steps to build your own cellular network. So I have provided the links also here. You can use these links to bring up the AGW as well as to spin an orchestrator locally or in the AWS cloud. So yeah, so now we have a wide variety of ARM devices from our ODM partners, and you can build your own fixed wireless or private wireless networks by following these steps as well as the links. And as you all know, CBRS is unlicensed spectrum, and it is free in USA. You have all the software and off-the-shelf ARM servers available to you to build your own cellular network. So next, I would like to discuss about the roadmap on the ARM architecture. So OAI team, Open Air Interface team, is actively working on traffic CI enablement. So far in Magma CI, the S1AP test is based on Vagrant VirtualBox environment, which doesn't work on ARM architecture. So towards that, we have decided to set the Magma roadmap to come up with an S1AP test which runs the containerized AGW image on both x86 and ARM architecture. Sagar, Arora, and Frank from OAI team, they are already working on running the S1AP test with the containerized AGW image. And once the S1AP test is complete, they will be working on 5G SA test, and the test topology will be very similar to S1AP test. So this is again in the future. So you can check with the OAI team for the timeline. And one other component that doesn't run on ARM architecture is orchestrator and federation gateway. So Magma DevOps, Shubham is going to work on enabling the orchestrator component on ARM architecture. So the advantage is once you run the orchestrator on ARM, you can run all these Magma components on the same ARM device. Basically, you can consider this as a network in a box. Ideally, I would like to run all the gNode B's, orchestrator, and the access gateway in the same ARM device, in a tiny form factor device, and I simply want to hook up a radio of my choice. It should be as easy as bringing up a Wi-Fi at that point. So there are no product available as of now, but I hope that those kind of products will be available from the ARM partners in the near future. So that's all I had. Thank you very much.
Thanks a lot, Govind, for the nice session. It gives really a good adoption of Magma in the community. Seeing that there are a variety of options available for the community to pick it up off the shelf ARM-based servers, and they could be able to bring up their own private 4G, 5G networks in the enterprises as well. It really gives a very good feel that Magma is going to become more bigger and bigger. It's really a good thing. Yeah. So there are one question in the chat actually. So any of these setups are available for the community to try some test over here, Govind?
I have my setup, but it is not open for public. But the setup is not that difficult actually. As we said, you can even run on Raspberry Pi or M1 based MacBook and use SRS RAM and spin the orchestrator in AWS Cloud. So it should be very easy. So we don't have any test setup for public.
Okay. Yeah.
So,
Is ARM considering any of the labs to be kept open for community to try it out?
So there is some Terraform code that we have developed specifically for ARM, bringing up ARM instances on AWS. So we can, like, community can use that for spinning up new instances. And we have other deployment script for, let's say, deploying Access Gateway, the ARM based. So they can use that.
Awesome, Shubham. That's really a good thing. So the Terraform helps in bringing up any of the off-the-shelf ARM-based servers. That's what you are trying to find, right?
So we have the ARM AMI setup, and we have all the specific requirement and filled in. So if community want to adjust, they can just fill in the values, like they need some more CPUs or more hardware or something like that. They can just adjust it.
Okay. Okay. So it is right now available for AGW bring up, if I am correct.
Yes. So it's just an ARM instance setup that we have. But yeah, right now we are just using that for Access Gateway. Later on, we will be using this for other products. Right now, we have tested this for SRS RAN also, the ARM based one.
Based one, yeah. From the Govind's update, it is clear that there are containerized package itself is readily available, where people can go and just pick it up and bring it up, right? No need of even using a Terraform. So that could be much more easier if they have some managed Kubernetes with them, then they can just go and spin it up over there, correct?
That's right.
Yeah. But the question is, Govind, is there a way that ARM could open up some of their lab facility for the communities to use or get a feel of it, so that increases the adoption of Magma?
As of now, there is nothing exists. I can actually check out with our ARM team internally. So as of now, there is no offering for this.
No offering as of now. Yeah, that will be really a great thing as well, because it will give a good understanding about how ARM is really enabling the Magma, and that way people get to know the capabilities of ARM as well as the Magma side of it. So it really helps community members to get a good understanding of it. Maybe you can consider.
So tangential to that, right? There is one summit that is coming up in Seattle next month. Connect 5G team, they are hosting a workshop there. So they are going to, I think they are going to distribute solid RAM devices to the participant, not to everyone, based on the device availability. And they will be, you can work with them to bring up the AGW services on ARM devices. So workshop is more focused towards that.
Thanks for that update, Govind. It really helps people to know about it. So members who are attending one summit, they could get a hands-on of Magma as well as the ARM enablement of Magma inside that workshop. So that's a good news as well. Good. Any more questions from any of the members? The floor is open for questions. Anything for Govind in particular about, because Govinda spoke about a lot of the ARM products which are now ready to get deployed at a production level as well on the ARM side. So that's really a good list of.
Yeah, after just want to share one more information, how easy it is now to run a containerized image on ARM system. So I can build my cellular network under my cube. So so when I pull the Docker image, it just comes up without any issues. And we have provided those steps as part of in the GitHub. I have shared that link in my presentation as well. Hooking up a radio and then adding the IMSA number in the SIM. So this is a matter of 30 to 40 minutes, I think. You can power up your own fixed wireless network or private wireless network and use it as an IoT gateway. And you can use it in your college campuses or hospitals. You can use it for rescue operation, right? So we have many more use cases. Now it's very easy to build your own cellular network.
Exactly. Particularly in all the places where we have CBRS band available, which is an unlicensed band. So this gives much more flexibility to bring up a private cellular network over there. So in connection to this containerization, Govind, because you are again from the TSC member as well. So is there a plan and roadmap? Because it is for you and Yogesh might be to get a fully containerized Magma AGW, because right now the OVS stands out, right? So is there a plan from the TSC that it is going to be taken up?
No, Parthiban. So we have not spoken about containerizing OVS also because it's running as part of the kernel. If OVS runs in user space, we can wrap it up in a single Docker image. So in the past, we discussed about it, but as of now, we don't have plans to build a single Docker image, which includes the OVS data plane as well. There is no such plan. Yeah. But what we have done is we have uploaded the OVS packages in the JFrog Magma Artifactory, and the Ansible script, when you run it, it is going to install the kernel modules of OVS and then pull the Docker image. In terms of user experience, there won't be much difference. Whether pulling a single Docker image or running an Ansible script, it's running another script for the user. It's as easy as that.
Yes, that's right. The user experience on getting a deployment is much more easier, but there are folks from the other communities of automation and orchestration where they are trying to see an auto scaling features where they want to spin up containerized instances. Then getting the OVS into an user space becomes handy. So there are such expectations from some of the members as well. Maybe the community as a community, we should huddle together to see how that can be also done.
No,
Also,
okay.
So also we have the access gateway Helm deployment. So it doesn't work out of the box. First, we have to do the OVS setup that we are doing for the containerized. Only after that, we have to deploy the cluster, Kubernetes cluster. And on top of that, we can run the access gateway pods. And that should be like mounted with the host part of those exact volumes that we need for the OVS. So that's a issue that we may have to resolve if we want to scale this in future.
Correct, Shubham. Thanks for pointing that out. I think as a community, we all have to work together towards it. Maybe that's a good input for Govind, Yogesh to take it to the TSC and discuss this in detail and see how we could make those things happen.
Yes, Parthiban, in the past, we have discussed about running the Helm chart on ARM system. So TNG team, they said they will look into it in the future. I don't know about the timeline, but we discussed about it in the TSC meetings.
Awesome. Yeah, this is really a good update. Govind. Thanks a lot. We are at the top of the hour. Any more final questions before we call it a day? Okay.
Yeah, if any of you have any other questions, you can reach out to me in Magma Slack channel, and you can use my ARM ID, govindarajan.mohandas@arm.com to reach out to me if you have any further questions.
Thank you, Govind. Yes, all the presenters are available in our Magma Slack channel. Please feel free to reach any of us for any of the adoption queries or support queries. We are here to help you. We are in the message away. Yeah. Good. Thank you all. Thanks for participating. Looking forward for all your participation in the next upcoming meeting as well. Thanks all.
Thank you everyone for your time. Thanks. Bye-bye.
Bye-bye.